Morning, sir. My name is Alan. Today I'm going to give a presentation on the topic uniform linear arrays. What is an array? So, an antenna array is a group of two or more individual antennas that work together as a single antenna. The signals from each antenna element are combined. This combination creates a more powerful and focused signal in a specific direction that a single antenna could achieve on its own. So, here are the key advantages. There are higher directivity and gain, electronic beam steering, interference reduction. So the uniform linear arrays, also called as ULA. A uniform linear array is the simplest and most common type of antenna array. It gets its name from three key characteristics. They are uniform geometry, uniform spacing, and uniform excitation. The array factor, the interference pattern. The final radiation pattern of an array comes from two parts. Total radiation equals to pattern of a single element into the array factor. Element factor. This is simply the radiation pattern of one of the individual antennas used in array. And the array factor, this is the most crucial concept. The array factor describes the combination effect of all the elements working together. It's the interference pattern created by how the radio waves from each element adds up in space. Understanding the radiation pattern. It has a main lobe, side lobes, and nulls. Main lobe is the strongest, most focused beam of radiation pointing in the direction of desired direction. Side lobes. These are smaller, unwanted lobes of radiation in other directions. Nulls. These are directions where the radiation is cancelled out, resulting in zero signal. Electronic beam steering. One of the most powerful features of an array is the ability to steer its main beam without moving any parts. So, how it works? By precisely controlling the timing or phase of the signal sent to each antenna element, you can change the direction where the waves add up constructively. Here is the principle. Imagine a line of people creating a wave in a stadium. If everyone stands up at the same time, the wave travels straight out. But if each person waits a fraction of a second after the person next to them, the wave will travel down with this delay. We, we can steer the direction of wave. Phased arrays same with radios. Do the same with radio waves. Broadside and infrared arrays. In broadside array, the main beam is directed perpendicular to the line of array. It radiates a broad sheet of energy. And infrared array, the main beam is directed out from the end of the array along its axis. Important design parameters. So, beam width. This measures the width of the main lobe. A narrower beam provides higher directivity and resolution. Directivity, a measure of how well the antenna concentrates power in a single direction. Grating lobes. If the distance between the antenna elements is too large, then the array can create unwanted copies of the main lobe in other directions. These are called grating lobes and are highly undesirable because of the waste because because they waste power and create unwanted noise. Applications. Here are some of the applications. They can be used in radar systems, 5G and wireless communications, sonar, radio astronomy, and medical imaging. And that's it. Thank you.